Lesson 2.6 deals with graphing inequalities. We'll be graphing lines with inequalities, and we'll be working with absolute values a little bit. So this is a pretty simple lesson. When graphing inequalities with two variables, we want to indicate all ordered pairs that make the inequality true. So we'll have a x and a y. We want all ordered pairs that make it true. So what we're going to do is we'll be graphing our lines and our absolute value equations as normal, and then we'll take a look at the inequality sign, and that will tell us a couple other things. So if the inequality has a greater than or equal, you shade above the graph. If the inequality has a less than or equal to, you shade below the graph. If you have a less than or greater than sign, it doesn't have the or equal to, but if you have a less than or greater than sign, use a dashed line because the points on the line or absolute value function are not included in the answer. And I said function, but they're actually not functions. If it's got the or equal to, you use a solid line because the points on the line are included in the answer. So we're going to use those different concepts as we work through these. So graph the following inequalities. Well, this one right here, it would be easier if we put it in slope-intercept form so we can subtract 2x from both sides. And that gives us y is greater than or equal to negative 2x plus 5. So we put it in slope-intercept form, and now we're going to graph. Y-intercept is 5, 1, 2, 3, 4, and 5. A slope of negative 2, so we can think negative 2 over 1, go down to right 1, and we can continue doing that for a bit. And then we're going to graph our line. Now let's look at our inequality here. It's a greater than or equal to, so it's going to be a solid line. So we're going to have a solid line. It's in white. Let's go ahead and change that. And we don't want dashed. We're having trouble here. Solid line. Going through those points. And then we want to shade. It's greater than, so we shade above the line, so higher than the line, so that ends up being this part of the graph over here. And so we can shade all of that in, and that is the solution to that inequality. So any point on the line or in the shaded area would make this inequality true. Going to the next one, it's written a little bit differently, but it's just saying we want the relation all x and y so that 4x minus 3 is greater than 6. This one's a little different because there's no x there. So we're going to go ahead, there's no y. We're going to solve for x, so let's add 3 to both sides. So 4x is greater than 10, 9. Add 3 to both sides, you get 9. Divide by 4, you get x is greater than 9/4, which is 2 1/4. Well, when we have x is with a number, so if we had x equals 2 1/4, we know that that is a vertical line. So x is greater than 2 1/4. What we do is we graph 2 1/4 here. Try to make a straight line. There's 2 1/4, and now it's greater than. So which values of x are greater than 2 1/4? Well, everything to the right of this line. So we would graph, shade everything over here. Moving on, we have a couple absolute value inequalities. So as we look at this, from when we graphed absolute value inequalities, we know it's a V shape. We know that this 1 moves it left 1 because it does opposite of what's in here. It's whatever makes the 0, so a negative 1 would make it 0. And this is down 2. And so we normally have a V shape here where the vertex is at the origin, but it's going to be moved left 1 and down 2. And we still have our V shape, so it will come up here. And I am using a solid line because it has the or equal to. And are we going to shade above or below our graph? Well, that's a greater than or equal to, so we're going to be shading above. So it's going to be everything up here. So all the points on the absolute value graph and above it will make this inequality true. Coming to our last one here, y is less than the absolute value of x minus 3. So this 3 is subtracted on the outside, so this is down 3. And so we take our v, we move it down 3, and we have less than. It doesn't have the or equal to, so we're going to have a dashed line. And it's a less than sign, so we want to shade everything below our graph. So we want to shade everything down here. And that is how you graph inequalities. So similar to graphing lines in absolute value graphs, but you have to think about, do you use a dashed or solid line, and where do you shade?